Okay, should we ready go? All right. Well, as most of you know, my name is Andrew. Been here for a little while, probably February, I think, was when I started. But I've gotten some chances to work in the CCC project on AWS. Unfortunately, as I was developing out my presentation, ended up doing a little bit less AWS than I was hoping to do, but maybe there's some room for a part two in there, and hopefully if we have time, I'd like to do a little bit of a demo, at least at the end. At least show off like the dev console and kind of explain a little bit better what some of the different components that AWS offers are. So yeah, go ahead and get started. So one more thing I'll mention too is if you have any questions, feel free to interrupt and ask at any time. I like doing interactive presentations. Makes it a little easier and makes me less nervous. So
Yeah, Andrew, I have a question.
Yeah.
What is scalability?
Is that Scala? Scalability is the ability to grow with demand without losing performance. You might be able to look it up and find a different definition. I think I just kind of wrote that one down off the top of my head. But essentially what you see a lot of times when you're developing is you're working on your own local machine, you've got your server, and you're not really going to see any performance problems, hopefully, because you're not really hitting the server. But then when you start to get a lot more, and even with 2, you wouldn't see it, maybe 10, you won't see it. I'll actually bring up this graph. This is an ideal system. You would get equal bang for the buck. So I pulled this off of the internet. I'll have to try to find a link for it. I don't have one, but the ideal system, basically, the throughput is going to scale exactly the same as the load. So you get that perfect line there. So if you had 10 million clients, you would be able to do 10 million times the throughput. But unfortunately, there's a couple of reasons that in the real world that doesn't really work out. First one is the cost of sharing resources. So especially on our developer laptops, we have limited amount of resources. I have a 2.7 gigahertz CPU or whatever, and 16 gigs of RAM, which isn't bad, but I'm definitely not going to serve 1 million clients off of it, because as soon as you start to need to share those resources among the 1 million clients, you're going to run out of resources, and that's going to start to slow you down a little bit. Diminishing returns from contention. Contention just means trying to use the same thing. So if there's essentially the same resources are going to have contention. So if people want to do this different things at the same time, my CPU can only do so many things until it needs to have somebody wait, and you're going to start to see at the red box at the top, it starts to drop off a little more significantly. And then negative returns from incoherency. So as soon as you start to overload, for example, the memory on my machine, it's going to start putting stuff onto disk, and then it's going to have to spend some time figuring out what it needs to pull off of the disk, and then actually pulling that off of disk before it can send that back. So that's when you start to see like this peak here would be about the time you probably fill up your memory, and you're going to have to page out to disk, which is going to really start to slow you down. So these are some of the typical problems you'll see with scalability in the real world when you start to actually serve multiple clients, and when you get to a much bigger scale. So traditionally, scalability meant something that's called scaling up. So the good old days of processors, we started out, I actually have no idea what we started out with, but say 200 megahertz, and then the Pentium 2 came out, it's like 400 megahertz. And then continually you would keep getting better and better CPUs with each chip cycle. And so basically you could write crummy code, but your program would just get it faster as soon as you installed a new processor. And that continued for a while, probably till the Pentium 4 that started to get up to the 2 to 3 gigahertz range. can't quite remember, but unfortunately, as I mentioned, it's not sustainable. So about 4 gigahertz is what they're finding to be the limits, at least reasonable limits. If you grab some liquid nitrogen, I'm sure you could take it a lot higher to like 6 gigahertz, but that's kind of expensive, and so not really feasible for most people. And then if you wanted to go higher than that, you'd go to IBM for a mainframe, which, I mean, technically is still a distributed system, but it gets really expensive really quickly. So now what we've done in response to that kind of unsustainability and the fact that we're realizing we can't go any faster than 4 gigahertz is that we've started to scale out. And that means multi-core processors and then multi-machine architectures. So kind of the cloud that you'll hear about where you have multiple machines doing the same thing. And essentially that's a lot of what I'm going to talk about for the rest of my talk. And on top of that, we're using commodity hardware, which pretty much just means you're not using a mainframe, you're not buying anything from IBM, you're just buying whatever, a Dell computer with an Intel processor and some off-the-shelf memory components, and you just buy a lot of it, and you write your programs to be able to utilize a lot of those resources concurrently. So they're Intel and AMD, not IBM. Also brought about the birth of the term cloud when we started building big, gigantic data centers that are essentially all being used for one purpose. One of the cool things I've heard recently is that the way Google likes to think of their data center is that it's just a big computer. So they built their networks so that they can treat essentially everything that they do over the network is just another call to a different, and you don't really care which processor is going to be computing that. So how do we write systems that can scale out? Obviously this is a pretty deep subject. I remember initially when, okay, happened here.
Might just stop sharing every share.
There we go. So as I was saying, I remember when I was using Photoshop and I got a dual-core processor for the first time. I was really super excited that it was going to be a lot faster. And I think whatever, it didn't really matter back then, I don't think, but went to try to do something and, sitting there waiting, and I look at the CPU usage and it's at 50%. So it's like, what's going on here? Why is it not using my full CPU? Turns out you can't just automatically use multiple cores. You actually have to deliberately do that. Usually in operating systems, that's with threading. But I'll talk about some of the higher level concepts. The first one is to distribute, which threading is just one example of that. And really what you'll see is a lot of these are overlapping, but I wanted to call them out individually. Next piece is to decentralize. That's kind of a hot word today, really popular. Defer, and to keep your code dry, so don't repeat yourself. Which really kind of applies across more than all of these. I think apply to more than just scalability, but especially it's scalability. And it really ends up being a lot like sustainability, which you hear the term or the phrase reduce, reuse, recycle. What you really want to do in scalability is to reduce the amount of work that you have to do for each product, I guess. This is going to be fun.
We're not necessarily saying.
It's nice to see your face every once in a while.
I mean, here's the argument, I guess, is that we are fetching everything.
We're what?
I said it's nice to see your face every couple slides.
Was Matt saying something, or is he talking to somebody else?
So we're just
I think Matt is on a call still.
Okay. All right. So reduce, reuse, recycle. What was I saying? Yeah, try to reduce the amount of work you do for each thing produced, I guess, each product. Reuse the results of that work, and then recycle what you can, which kind of, same thing as reuse, I guess. Maybe there's less recycling in distributed systems, but so the big one, which really kind of more of an umbrella, I guess, is to distribute. So one of the most important things in writing distributed systems is statelessness. You'll hear this a lot in the context of REST, and you'll hear it a lot in the context of containers. It's pretty popular to talk about stateless containers. And when I say containers, I mean application containers. So the important thing is all the information that you need to do whatever is in that container, whether that container is an HTTP request, maybe I should have called it a thing or something, or that container is actually an application container, as you would see with something like Docker. So in the case of HTTP requests, you want to make sure all that your user information is in the headers, that you're identifying the exact resource you want, with anything that any constraints that might apply to that in the URL, so that no matter where this request ends up going, that server has all the information it needs to serve that request. Because when you distribute, you don't really know where your requests are going to go. And the same thing goes on the other side, which is the actual application container, or really whatever it is, if it's a virtual machine image or something. You want to make sure that all your dependencies are contained there, so that as soon as your backend starts to get a little bit bogged down, the server just needs to spin up a new one, or the orchestration service, I guess, needs to just spin up a couple new containers and start routing traffic over to that new load. So both of these, it allows you to spread the load evenly and to do that automatically, because, excuse me, you don't have to worry about managing sessions, especially if you can put all the state in the request, and you don't have to worry about installing dependencies or doing a bunch of management before you start up a new virtual machine. If your container, for example, has all of the dependencies it needs and all of the information right there. Oops. So the example I gave earlier, are your web servers a little bit overloaded? Add a few more, that should say add a few more web servers and just redirect the traffic. So to cover some of the AWS components that'll help you do this, the first one is S3, which just stands for Simple Storage Service. Hello. Keep doing that. So S3 stands for Simple Storage Service. I can actually show you a brief example. We're using this, actually, never mind, I can't show you an example. It's a specific client. But, oh no, wait, I can. astewart.co is a really terrible static site right now. It just doesn't even do anything. But this is actually hosted on S3. One of the great things about S3 is that as long as you have static resources only, you can host it all on an S3 instance, which is really just like, say, hosting it on a file system and putting Nginx or Apache up and running it as a web server. And they give you a really nice little REST API where you essentially you could just do a put request to a URL and make the body the file, and it'll actually start serving that if you configure it correctly, which makes it great for static content. Like if you have the next one, CloudFront, if you end up using CloudFront with S3, you can essentially have your own CDN, content delivery network, pretty much for free, just by putting something in S3, which, by the way, there's a really great Grunt and Gulp plugin for doing that. Just makes it really nice to, say, concatenate, minify your files, and then upload them to S3. So as long as you use S3 and CloudFront will actually distribute those across the globe to different S3 data centers, so that in combination, I think you may need to use Route 53, or it may do it for you. But Route 53 is the DNS server that Amazon offers. But essentially, if someone over in Singapore wants to download or wants to open up your website and it has some extra files like some JavaScript and a few images that are uploaded onto S3, it'll go to a Singapore data center, whereas somebody in California would go to the California data center. It makes that really trivial. So I think the document I read talking about AWS is like the first two of these, it lists as these are kind of the ones you get, or a few of the ones where you get that redundancy and that scaling for free. You don't really even have to configure anything, or at least not much. Some of the other ones, the services they offer is their relational database system, DynamoDB, which is NoSQL, and then Elasticache, which, if you've heard of Memcache, it's just a cloud instance of Memcache that you can write with your applications, or write to from your applications. ELB, that's the Elastic Load Balancer, which is essentially if you have your servers in EC2 or your containers in ECS, the ELB is going to basically, I think by default it just round robin sends all your traffic to a different backend server, which is why it gets very important to have the stateless requests in there, because they may go to any of your servers. So another one of the strategies that's really common is sharding and replication. You'll hear these a lot with databases. I know MongoDB likes to do sharding, and with SQL it's a lot more popular to do replication, although I've heard of sharding there as well, which essentially sharding is going to split your data off. Actually, I'll talk about that in a second. So if you notice that your reading information is happening too slowly, what you probably need to do there is you need to replicate. So, for example, what really happens there is you have one master for the writes, and that's going to send updates to the replicas. And then any read requests that come in, so if you're doing a select in SQL or if you do a get to an S3 bucket, that may go to the one that you wrote to, but probably not in reality. It's probably going to go to one of the replicas that had those writes sent to it from the master. And then if those writes are happening too slow, which is usually a lot less of a problem, the data is usually a little more static, but if you're operating at a scale like Facebook, you're going to need to start doing some sharding, which essentially you have servers that specialize in a specific group of the total data. For example, you may have users A through C on one server and D through F on another, and so on. Any questions so far? Am I boring anyone? Cool.
Some of the other problems that I want
it's good to hear all this. I think it's nice to have associations with the problems that are out there with kind of like the solutions that AWS provides. This is really nice to hear. I hear all these in talks with our other devs, and it's finally nice to get kind of a streamlined understanding of this stuff.
If somebody reminds me, I'll try to send out a link later. There was a good Hacker News article the other day. It was Amazon, or it was like AWS in English. They have essentially a lot of the same information, or at least they kind of go through all the AWS services and kind of explain what they do. Because if you look at EC2, ECS, Elastic Beanstalk, like what in the world is that? But yeah, there was a great article the other day.
So going back, I think 1 or 2 slides, you had you were talking about S3 and then CloudFront.
Yeah.
So would you ever use S3 without CloudFront, or would it be like maybe you have one instance in S3 and you use CloudFront to manage multiple instances? Is that how it goes?
I think that's literally what CloudFront is, actually. I have mine disabled right now, but it uses S3, and I think it essentially just replicates S3 buckets to different buckets around the world, and it gives you this think this is the origin that you get, where you can, if you load your content from that origin, it's going to go to the right bucket in the right global data center.
Okay, gotcha.
But yeah, you can use S3 without CloudFront, and you probably should until you actually need to use CloudFront, because I believe it costs a little bit extra money, just because it's going to be whatever 12 buckets instead of one bucket, and then it might, I don't remember if it costs on its own or not.
Okay, but CloudFront is pretty much tied to like S3. It's not like.
Yeah, as far as I can remember. Maybe not. So they have the, yeah, actually, I guess you can use a web server as well. So
There's a 16.
Oh, okay.
I'm most familiar with using it on S3, which is dead simple, but apparently you can use it for other stuff too. Like that's kind of cool that you can do like streaming media through that. So I'm sure that's helpful.
I'm breaking them up. We don't have any of those.
So my personal favorite strategy for when I'm trying to design a website to be distributable is to do as much static as possible. So I mean, that's a lot of what we end up doing when we write web apps and single-page applications. Is we write JavaScript that calls an API, and really the benefit of that is the only thing that is changing there is the data. So you call the API, you get some new values, and it renders differently. Whereas pretty much the old way was, you have a JSP up on the server, it's going to make a database call somewhere, and then it's going to get processed with that data, and you're going to not be very dry. You're going to end up sending the same chunks of HTML over and over with just a little bit of change. So the nice thing about static resources is that your servers and your backend needs to do the minimum amount of work, and you can distribute and defer that to the client side. And it really ends up being a great balance of flexibility, because you can change that data, and hopefully you've designed your pages and your application to be able to work with that data and be very flexible while saving costs, because you're not actually going to incur the render on the server unless it's an API call, in which case, if nothing's changed, you can even just send back whatever it is, not 302, like whatever the cache, use your cache copy. I don't remember what that status code is. It's like unchanged or some status code for that. I don't remember what the number is. So to elaborate on that further, when we use our static resources, so we have the JavaScript and compiled CSS or whatever, if you hand wrote it, you put those in S3 and use CloudFront, and that gives you basically really trivial way to avoid having to do a lot of work, because the client is just going to pull those all at once, hopefully, and it's just they're trivial to distribute. You don't even have to think about it. It's just a file that doesn't change. It's always going to be at the same URL, and if you're using CloudFront, that URL might actually point you to a different data center, but you're still going to get the same exact resource. I mean, really, that's one of the biggest benefits I see for using a single-page application, is that you get to do something like this, and then just make the calls that you need for data and never do any work you don't need to. You just re-render only if that data has changed. Another strategy for making for avoiding work is to pre-process when you can, and that usually means and so like doing the work once and sharing it across all of the different uses, you can amortize that cost for each client or for each request. So one good example, I don't have it. I guess I have a couple examples. So when you have slow-moving dynamic information, like possibly one of these, especially if it only changes every time you build, like if you need to change it when you do a prod build so that it now says something different in the title, just try to put that in your build process, for example, and then you're not going to have the server render the title each time. It's automatic, or it's static in there and inside an HTML file. Another one, copyright date, version number, cache busting strings. There's a really great, I think it was a Grunt plugin, but I'm sure there's one for Gulp that I've used before. I don't know if it was randomly generating them, or it must have been a hash because it knew when a file had changed. So you could set everything to be cacheable except your index.html, and then if any of those files changed, the actual string for it would change. So none of the caching layers are gonna hit that. But another option you can do, rather than a build step, is say have a batch job that runs and it updates some S3 buckets, which then will automatically get distributed by CloudFront. So say you have something that only changes every hour. This is a viable way to do that and not have to worry about rendering it each time. You can avoid the cost there. So cache, cache, cache. Never do anything yourself that others can do for you. I've never read this book, but I thought it was a really interesting quote, and I thought it was pretty applicable to caching. So the benefits of caching is that when work comes in, especially if you have work that is fairly dynamic, but can still, but you don't necessarily want to do a batch job for it, you can have a cache layer set up either on your server inside your application, or as you see in like some of the REST documentation from Fielding's dissertation, he talks about just multiple caching layers, and this is one of the problems you can run into with, I know IE is really aggressive about caching, and then on a lot of corporate networks, I know we used to have at my last job, we had a cache server that was a proxy, sat in front of every request you made for a website, and if it had a copy from, say someone else in the company had made a request, it would grab that out of its cache, and there's actually headers inside of HTTP to manage that. And the goal is that you don't have to make redundant requests if you don't need to. And then you can wait to render it. You can actually defer the rendering until it's requested the first time, and then just tell everybody down the line, well, don't hold on to it longer than this, but you can hold on to it for this amount of time. And that's what I'm talking about here. It is tunable with the time to live headers and multi-layer, as you see in Fielding's document. This is right out of the dissertation Fielding gave. It's hard to probably see, but there's this $sign that he uses to indicate that this client also has a cache when it talks to the server. So it's gonna check that time to live field, the TTL, and if that amount of time hasn't passed since the last request, it's just gonna take it out of disk or out of memory, which is gonna save you a lot of time. Oh, I don't think I got the latency numbers in here. I'll have to see if I can find that later.
Hey, Andrew, I think that's an excellent slide too, because that $sign, every time you can leverage someone else's computer, then you're saving yourself money.
Yeah.
It's a huge deal.
He must have had another picture later on that I just didn't get to, but he talks about essentially layers of these nodes where, kind of like I talked about with the corporate network, you might have a cache that helps out a bunch of other clients, and that really can take the load off of your servers where they've done the work once and they don't need to do it again. This is, if you've heard of, oh no, I'm not going to remember it. I forget who it's essentially a CDN, and I know they're used by Hacker News, and I think it's actually a Y Combinator company. But there's a company out there that does stuff very similar to this, where it'll cache the results of any dynamic call for you, and then it'll actually send that out to a CDN. So a page like Hacker News, you may not actually be going to the original. You're definitely not going to the Hacker News website or the web server, you're going to one of, it's not CloudFront because that's Amazon. I don't remember. Cloudflare, yes, thank you. So yeah, Cloudflare does very similar, or exactly this, and they made a really good business out of it by doing it well, because then it takes all of that thought that you may have to put in and just does it automatically. So another strategy that's really common is to specialize. This is, a strategy that's been around for a really long time, with the idea of, you only have one virtual machine, or one machine even really just for your database, and then you have your application server, and you don't want to put those on the same box, but now you might put them in the same, or on the same machine in different VMs, or even now in different containers. But the idea is that you want to make sure your hardware is specialized for the application. And Amazon gives you a couple really nice things to do this. I've talked about most of them already, but they have services where you can just use the service rather than actually spinning up a virtual machine with a database on it. And they'll manage the backups for you. They'll manage the elasticity, they call it, scalability. And they do that all for you. One of those examples is RDS. Another one is S3. But for example, you wouldn't want to do data caching in RDS, because that's built more for persistence. Again, RDS is the relational database service or something like that. Databases as a service. So you don't want to do your caching in there when there's something like Memcache, or I guess Elasticache, where it's built to be all in memory and really speedy for access. And on the other hand, you wouldn't want to persist your data in Elasticache. Even though it's really fast, it has no guarantee that that data is going to be there if the server goes down. So you want to make sure that you're persisting in RDS, and the nice thing is that they're going to have that specialized hardware for you that you don't have to worry about. And you want to, any caching that you're doing manually, or any memory that you need quick access to, especially user session data, you put that in something like Elasticache, where it's going to come back really speedily, but you don't really care if it dies, because you can always get it from that database again. So that kind of wraps up the distribute, I think was the first term I had, and brings us to decentralize. Really, this is a little bit, it's just kind of a more specialized term within that distribute umbrella. But a lot of the ideas you see in modern clusters come from some of the decentralization, where this is one of the things you see is that federation is a really common term when you talk about decentralization. The ability to essentially elect a leader is pretty common. A lot of algorithms, there's Raft and Paxos, I think, are the two most prominent ones. Basically, if you start up 50 database servers, or 50 whatever servers, out of the blue, and they have no idea, like there's no existing leader, these algorithms exist to actually go out and essentially, I think they actually call it election. Oh, hello. So these algorithms will help, or yeah, they'll go out and elect a leader from all of the new machines, and then that machine will become a dedicated leader, and it can actually orchestrate the other machines and make sure that new data, for example, in like a database, new data gets written, and then kind of delegate responsibilities to each machine. And you see some pretty cool abilities to make collective decisions in these same systems. The idea there is that it's a lot like the Borg, where they always have that presence of mind, and they get to make the decisions together. And if a couple machines, especially you see in, I think Paxos handles this particularly well, where if you have some machines that start misbehaving and start saying essentially the wrong things or become malicious even, as long as not too many of them. I think it's usually as long as a third of them, less than a third of them are misbehaving, the cluster can figure out for itself that what's going on, and then react accordingly. One of the really important things for any distributed system, is discovery. So we have a lot of distribution. We have a lot of servers that may be started up in a bunch of different places. They're all going to have their own IP address. And you need to be able to make sure that you can find the services you need. Because if I'm writing a web app server, for example, I'm going to need to know that I can access the database server, but there may be 5 of them. So I need to figure out where the database is before you can actually talk to it. So the most common strategies are that they all have to use really well-known names, which just means essentially that your developers have agreed ahead of time that this service is going to be called something. You may tag it and make it searchable, but ultimately you need to make sure that your code has the right name in the right place. You'll see that this in stuff like Docker links, where a service is known to be running under a specific name, and then you're going to link to it. One of the oldest strategies is definitely DNS. Route 53 is Amazon's DNS provider. I think that first one should have been a bullet point. Sorry about that. So with DNS, there, especially one of the most common or one of the most helpful records. There's a bunch of different record types in DNS, and one of them is the service record, which I don't think is actually very commonly used, but is really useful for something like this. Essentially, you can say there's this service that's going to run on this, or this service name runs on this port, and then you can have that distributed across multiple IP addresses. Usually a DNS record is only going to have one name and one IP address, but the nice thing about service records is you can add a bunch of those, and if you have that dynamically done, then you have the ability for any brand new web server to say, ask for give me database dot whatever at foo.com, and it'll actually return a list of database servers, and then you can, usually I think it's just you select one at random, and then you hope that everybody doesn't randomly select the same one, which is probably not likely to happen. Okay, yeah, I don't know what happened there. Another common strategy is service discovery. There are a couple open source tools for this. I think Netflix is probably one of the most, awesome contributors. They have a lot of open source tools and documentation and great articles. And they have a service called Curator, which, again, most of these are for exactly the same thing that you would do with a DNS service record, but they're a little bit more flexible, and they enable additional things like your service discovery server can make sure that a backend server is healthy before it tries to delegate or return that as a viable option, or can say, well, it's a little bit overloaded on that server right now, so I'm going to keep that one under wraps for a little while and send it over to some of these less used servers. Anyway, Netflix Curator is one example of that, and Zookeeper is another one that I keep hearing about. I haven't had a chance to check it out, but I've heard good things. So another strategy that we use a lot in order to build scalable systems is to defer as much work as possible. You kind of see this with caching versus batch jobs. Sure, okay, that was good. So we really want to be lazy as much as possible. I'm a developer, that's why I got into it, because I could make computers do what I want, and then I didn't have to do it anymore. The same thing goes for building distributed systems. You definitely want to make sure that you're doing work only if it needs to be done, for the most part. So only do the work when you need to, which means basically prefer caching over cron jobs. A cron job may make a lot more sense if you already have a ton of traffic, but if you or especially caching is specific to the amount of time that has passed since the last request. So if you need to make sure that the hour is updated every hour, you'd want to do a cron job instead and just set it to go on the hour. I guess you could add intelligent caching to change the TTL there too, but I think it's just generally easier to use caching. So then the other thing, which we do a lot in single-page applications, is to only do the work where you need to. This means rendering user-specific information, for example, at the user agent. So in a single-page application, you make a query to the database, you get some information that's specific to only you, like you have, say, your private to-do list. I think, personally, this is probably a little bit more of a controversial one, but it tends to be where I like to put the work, is just to have the user agent render that. I think the most common excuse I've heard for not doing that, well, there's two, I guess. One is you want to make sure you're not overloading the client, because JavaScript is single-threaded, so you only get one core, and you want to make sure that you're not destroying the user experience, and you're going to have a lot more power on the servers. So my response to that is always, well, just benchmark, and then if you really do need to do it on the server, go ahead and do it on the server. The other excuse, or they're excuses, but they're good excuses. Or the other one is SEO. So it's and my answer to that one tends to be that I'm a little bit annoyed at Google for not catching up to where, I mean, they obviously did pretty well when the web was all static and returned as HTML, so they should just get on board and start doing single-page applications a little bit better. Last strategy is just applicable to programming in general, is don't repeat yourself. So really, especially in your data, you want to find patterns and eliminate it. If you can avoid making the same HTTP request over and over, find a way to do that. And that'll really eliminate a lot of the database work, or the, I wish I had my latency numbers here, because essentially, like, if you have your information in memory, it's going to be, I don't know, like, I think it was 300 nanoseconds for your CPU to address that memory, find out where it needs to go. Even if it's like a convoluted object, 300 nanoseconds is probably a good amount of time. But even, let's say it's a millisecond. But then, say you need to go over to the web server, even if you're on the local area network, that's going to take probably 2 milliseconds. And then if you're on, like if you're talking to a Google server, it's probably going to be about 80. And then if you're on mobile, I think it goes up to about 400, depending. I think that was 3G. I think the 4G numbers were better, and bigger sounds better. So every call you avoid making is a huge amount of work and a huge amount of time that you can get rid of, and that's going to result in a lot snappier user experience and a lot less load on your servers, which means that your application is going to be more scalable. Some of the examples I really like to give here are the bitmap format versus JPEG. Back before we had JPEG or any of the compression formats, if you had a 400 by 400 image, that was 400 times 400 times 32 bits for each pixel of data that you needed to store. But then somebody looked at the picture and they realized, like, hey, this area up here is a whole lot of blue. Maybe we can just say that this area is blue, or there's a lot of complicated algorithms to figure out how best to compress it. Did I show anything? Yes, I did. And you really end up using a lot less information there. And a lot of times we can do the same thing with our data. I mean, with a single-page application, you kind of get some of that out of the box, especially with Angular, because you don't have to send, if your header isn't changing and you just have an ng repeat on the page, and you're querying the database server, or you're querying the API server, if you get new information, you're not ever having to retransmit that header, whereas if you're doing a round trip for each page, you're going to have to retransmit everything on the page, and then your browser's going to have to double check that all those scripts and all the image tags haven't changed. Hopefully not have to actually re-download them, but at least get a response from the server that, yep, you do still have the latest copy. And then, so that's one example. Probably my more favorite example is GIF versus MP4. I don't know if you're familiar with the GIF and the GIF format, but essentially what you end up with is a JPEG for each frame. And whoever it was that developed MP4, Matroska or something, had this kind of the same realization, except that, you know, when this is a video, if you just want to pretend that you're looking at a video right now, like those clouds are maybe moving, but the sky is not moving. So as essentially what MP4 can do is it picks a block in the sky, or in this case, picks a block that doesn't really change. In this case, that would be the sky, and then kind of just lets the basically whoever's watching the video is actually going to do the work to put everything back together, but you're really only using data for what's changed in each frame. So as I guess the analogy there that I like to use for the server side is that that's where using something like an HTTP patch, where you're only sending the data that's changed, or you're only asking for data that is changed after the last thing you have in your cache. You can get even further savings by not having to retransmit that data, just retransmitting or just transmitting whatever is new. So anyway, I think that is pretty much all I have as far as slides go. Were there any questions? Anything to clarify?
Can you maybe talk a little bit about, you know, how far you've gone in your own personal work, like maybe like a high-level example of what you've been able to accomplish in AWS? And then like how much time? How long does it take to get?
Probably the best example right now is I don't know. I'll talk about previous work experience. So at my last company, we were working on a time entry solution, and the ones that were going to be the heavy consumers were the supervisors, who essentially at the end of every week, they were going to download all the data from all of their foremen, which might have been like 200 guys who had clock in, clock out records for the morning, and they had their lunch, and then they had clock in, clock out for the afternoon. So we had to figure out, because we didn't want to do just a whole bulk download for each time. That was good. We were using nodes, so that would have locked up the server for a little bit, and it would have just been wasteful. So what we ended up doing is caching a lot of that on the actual device. It was done on an iPad with PhoneGap, and so we would put that in local storage, and I think we ended up using IndexedDB, but it was there's a library out there, I think Mozilla wrote it, called Local Forage, which just uses IndexedDB as a local storage with more storage in it. But we ended up using that to basically save all the time data, and then we would just find the most recent timestamp and ask the server for anything after that, so that we could avoid retransmitting that data. And then there was also, we used I think it's called a tree, TRIE structure, to avoid doing aggregate calculations every time anything changed. Yeah, a lot of the principles. So I mean, we tried to avoid repeating ourselves by using the cache data. We deferred as much as we could there was no web server, so it was all the Angular application. decentralization, we didn't have as much of that. It's a little more common on the back end, and we really only had one web server at the time. But then we tried to distribute. We used a MongoDB in the back end, and a lot of the caching and is applicable in that situation. And honestly, I would say a lot of the time that went into it was up front, but I really think it paid itself off in the end by using a lot fewer resources, and essentially we had the design that we wanted from the beginning. I think we had to change a couple of things, but it was mostly kind of an architecture level discussion at the beginning, like how do we want to do this and make sure that we're using as few resources as possible. Unfortunately, that was not in EC or in AWS, so I haven't done much of this in AWS. I have had the opportunity to do I've got my personal website, and we've got some static clients. There we go. Some static client files that are being hosted in S3, but we're still kind of a little ways out, I think, from actually getting hit by a lot of traffic and seeing how uPortal performs under high load, especially with some of the new strategies we've taken, which I guess I could speak to that a little bit. We're definitely changing up the way that uPortal does a lot of things. For the most part, it's actually being rendered by the front end now and just making calls for each individual portlet. And I'd like to see that change to when a portlet supports it, we're going to just do a data call and we're going to get a directive or a template or something instead of actually getting the full HTML fragment, which is the way it still stands for the most part.
There's something we want content in Mongo.
Cool.
It's just difficult to figure it out.
But if you could, I don't know if it's possible, if you could compare maybe the learning curve of AWS to Angular, and what you've been exposed to, at least in AWS.
It's pretty comparable, I think. Actually, there's a lot of things that they have that anywhere else would have a really good name. But I really like the article I saw the other day because it was AWS in plain English, because they just really named a bunch of stuff really funny, which Angular kind of did that too with directives, and they invented the scope object, and not that it's not brilliant, but it took a little bit to understand what that particular component was useful for. And I found that, and I'm still finding that to be a lot the same in AWS.
Cool.
Does that answer your question? Or were they?
Yeah, it does. It sounds like there's a little bit of terminology and then learning the patterns.
Okay. All right. Cool.
Yeah.
So,
and one of the things they have some really great architecture articles. They have an architecture center. So, and apparently I think this is new, but they must give you CloudFormation templates so you can deploy these if you want and mess around with it. Which you got to be careful because that can get really expensive without realizing. I had a bunch of documents that I saw at one point. Maybe it's in these. Yeah, this architecture center I thought was really helpful they go through, especially if you pick something I don't know if there's anything in here. You find something that you're familiar with, maybe MongoDB, and then figure out how they deployed it, see what they recommend doing in AWS. It gives you a little bit more of a feeling of, all right, this is, I know I would need 3 servers, and they deployed 3 EC2 instances, so I don't know, it just gives you a little bit more of a familiar start, I guess.
Phase with these options in them.
Cool. Good to see there's
And
some documentation.
we can kind of
Yeah, like here's so they have, it's really small. it's like a 2-shard system with replicas within each shard, and then the configure servers and all within a VPC, which is just basically a virtual network.
Hey Andrew, this is Gary. It seems like scalability or generally performance feels a little bit like accessibility, like it's something you probably should just do. Mm-hmm. From your personal experience in researching this and implementations, like is there a way to have like a good sense of like when does it, like how do you balance the effort in doing it versus what you get out of it? Is there like do you have some practices or some like tipping points where it becomes obvious to you that you really need to invest more effort into doing it on a particular project, or is there a way that you identify that, or are there just always some practices that you put in place in any project? Can you speak to that a little bit?
One of the big things is estimating your user count. I think that'll give you a really good indicator as to how much of this you actually really need to do. Because if you were going to, even for a good amount of users, if you just do single instances of like an Amazon RDS server, that's going to serve a lot of users. Definitely, I would say one of the things I've heard is that you always want to include an application cache layer. So like whether that's Nginx or what is it? I can't remember it now. HA proxy, that's the other one. It's usually worth your time to invest in something like that because it's just really dead simple. You just tell it how long this resource is going to be valid for, and it'll avoid any calls to the backend server if it has a copy available in that cache time. But yeah, really, I think there's probably I'd want to spend a little more time thinking about it. I think, but there's like a kind of a hierarchy of things, a lot like Agile probably, where you just say, well, I've got X number of users, and then you figure out, okay, we're probably going to want to do the top X things in this list. But yeah, I'd probably put caching at the top of the list. And then yeah, there's a lot of libraries that make some of this stuff really simple too. So if you can find a library to do something, then just try to drop it in, and hopefully that's all you need to do. That probably doesn't answer your question very well.
Well, I appreciate the thoughts. I think that's just something that might be helpful for us to consider is how do you. It seems like just like accessibility or something else. There's a lot of effort that could go into setting up something that's scalable and performant, and it's worth it. I think that it's like the trade-offs, or how do you? Are there any kinds of tricks or best practices you've come across, or that you use to determine like how much effort it's worth to put into something versus the return that you get on it, and to bake those things in, or be able to talk to your client about that and its value, and how to maybe look at that and applying it across various projects. So just something to think about and discuss more. I'm going to have to jump off myself too, so I'm going to go first this time for feedback real quick, and if there's other questions or discussions, go for it. Jeff, I think, is going to facilitate the rest of it. So Andrew, I think the things I liked about your topic in your presentation, you had a nice pace through your slides, and you went into some really good detail about different aspects of caching and scalability, and kind of where that started, and some modern resources around that. I think for me, it would have helped to have some more specific examples. So I liked, for instance, just when you went into some of the details around the image and video scaling and the formats that were used for that. So just a tangible example for some of those things helps a lot for someone like me. And then I think, and I'm probably doing it myself, something that I just noticed listening to you, especially not being present, is they used a lot of ums in your process, and when you would pause and things like that, some so bits that just for all of us, I think, to work on trying to reduce that out of our habitual pauses, or what they call crutch words for presentations. So really appreciated the topic. I like that you stepped through it. For me, some more tangible examples would be great. But I think it's real appropriate for our thought process, and I think that thought about how do you know when and where to apply some of these things when you get the value out of it would be something to discuss further. Thanks. Gotta go.
See ya. So if there's any more questions, that's cool, or I guess we can move on to feedback too.
So one thing I'm seeing, you might have touched this and I might have missed it, was for your scalability, obviously your static resources, but how would you handle your dynamic resources? Would you still just do that on your primary web server?
Yeah. So that's really you just want to make that your kind of last fallback. It's obviously like you have to have it because some of that data is going to change, but for the most part, I mean, my rule of thumb is anything that's data goes. Like, if you're going to put it in a template, try to do that on the client and then use an API server. So that really you're just kind of grabbing it out of the database and turning it into JSON or whatever. And checking security, whatever else you need to do. But yeah, it is really, like Gary said, it's a lot of kind of just a mindset, trying to make sure that as much as possible your resources are static. Trying to think of any other examples where you need something dynamic. And definitely legacy systems, like we're doing in uPortal right now. A lot of pretty much all the portlets right now they do render full HTML fragments, and then before the backend server would put those all together, but now we're just doing that on the client side. So we're still using dynamic sources there, but ideally we'd want to move away from that.
I was going to wonder if something like that, where you have JSPs that do the includes. I know there's two different types of includes. One where it gets rendered, basically the content does not change, so it's get rendered here.
So
then there's the include at runtime, so that every time it gets viewed, it's going and changing things on the page. So I just wonder if there'd be a way to go and push those static JSPs or whatever out somewhere and serve those up from here, and then have this here. But then it's like, okay, well, then how do you route? Yeah, so if this
so that'd be kind of tricky
here or anything like that. So
I wonder if you could just switch it to an ng include. Probably not, but
yeah, I don't know.
Yeah, I'm sure you could probably come up with a strategy to make that an Angular template or something, and then just grab the dynamic portion.
So I know, like in Shibboleth, they were doing everything in iframes. So in theory, I would think, depending on the way it's architect, I don't know the ins and outs of it, but if the whole shell of the portal framework, once it's built, that could all be considered static. That's not
right. Yeah.
Obviously, the contents, which are in the iframes, that would change, and that could point to wherever. But everything else, I guess, in theory, could host it in multiple places.
Yeah.
But it is Java. So.
Yeah. Yeah.
Cool. Yeah, I was looking at Cloudflare, I think, for CDN. Just personal sites. It's like, just play around with it. Something to play around with it.
Yeah.
I haven't done much with it.
And they're actually another one of the companies I really like. They do a lot of nice blogs on how they do what they do, and it's a really good source of probably some of the same information I've mentioned.
Yeah, I was always I know everybody says the AWS is free, but it seems like every time I've looked at it, it seems like, okay, it's going to cost you money. I'm like, I don't want to spend money to just play around.
Yeah.
And
They
anything,
have a free
anything
tier.
expensive fast.
Yeah.
Like you said.
They have a free tier, but it's one. You only get one.
Yeah.
And I couldn't even figure out how to get to the free tier. Like you have to. You don't just choose the free one.
Yeah.
You have to make sure you set it up right. And I didn't. I just like, you know what? It's going to cost me 8 cents an hour or whatever.
Yeah.
I think it's way less than that, even like 3 cents or something.
Still.
But then the other thing I got into is I was playing around with their APIs, and I'd spin up 5 servers and shut them down. But that's 5 hours right there. So
Adds up fast.
yeah. So I do that just messing around like 5 times in a row. That's 25 hours in the span of 5 minutes.
Cool. Anybody else on the phone have any questions? Okay. I'll stop the broadcasting for the feedback.